Hello, I'm Sónia Antón, and in this talk, I'm going to talk about all the data that's around and that you can download and that you can use. This data is available either in data archives or in databases of published data or in surveys. And I'm going to illustrate this with some examples concerning radio data, as well as data at other wavelengths. So let's say that you have observational time. So you submit a proposal, you got the time, and after obtaining that data, what happens? Well, the approved observations are accessible for you and maybe your proposing team, but they are accessible only for you for a limit period of time that can vary from say 1 year to one year and a half, more or less, um, depending on the observatory and other things. But let's say that it's after some time, those data become public. And they are available for the rest of community in data archives. These data archives can be accessed by, in general, by web interfaces, and in principle are easily to be accessed. The data can be in different stages of analysis, can be raw data. You can download the raw data or data that was already processed. Now, the point here is that we have major amounts of data that can be assessed. And in here, I want to give you some examples. There are more, of course. It's just to illustrate the type of databases and the archive data that is available. And I begin by Australia Telescope Archive. It's online. If you go to this address, there is this environment that you are going to find. And here you can query the data archive of Australia Telescope in different ways. What I'm going to describe here is quite common to other data archives. You can query the data either by a region, say that you are interested to understand which were the objects detected in a certain area of the sky. So you can put here the coordinates, the central coordinates of a region, and then say the, 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 the radius of the field of view that you want to analyze, to take data, or say that you know a project that was focused in some area that you are interested, and so you know the project code. You also can query through the project code or the observer surname. You know that someone had a proposal on some subject and you are interested, you also can do a query, or and then you can fine tune your query, say by frequency or type of array, etc. I'm going to illustrate some of the queries along the talk with this example. This source is 3C279, it's a quasar. And if I put the coordinates of this quasar here in this web page, I get this result. So this object was indeed observed by the Australian telescope. And the first information that I get is the list of the proposals in which this object was observed. So there is a large list. It's a very known object. And here you already know a little bit of information. Is for all these proposals, the data is still not available, so it's not public. So I cannot do too much. I cannot download the data. But for instance, from here to the list is big, so there is more proposals. This data here is available. So I could, in principle, download the data. Also, in this web interface, you can get information about very nice information. If you click in each of the proposals, the software gives you a lot of information about the proposal, frequency, time, and conversion time, scans, etc. Another example, it's the European Vlbi archive. So if you go to that address, you get this environment here, and you have different pieces of information. Let's say that we want to do a search archive. So I could also browse a catalog, but here I want to do a search based on the coordinates of an object. And if I do that, I go, so I choose here to search the archive, and I get this Finder tool. And again, here I can search, and I can find my fine tune my search. But again, here I prefer to leave it as it comes and just put the coordinates of my object and choose a radius. So inside a certain region of sky of a radius that I'm saying it's 1 degree, I want to know all the detections that were are in principle that can be in the data archive of EVN. Okay, I do so. I get a list, again, a list of proposals that that contain observations of this source. And if I go, and already the list gives me some information, the date that observations happened, frequency, the PI. And if I choose one of them, in this case, I chose the first one, just to illustrate. I get a lot of information here. So here, all these tabs give me information on the data itself. It's in this tab. And if I click, I get the files that I can download, and then I can process them with and view them with, for instance, Casa. Another example is the ALMA archive. You have also a lot of data available at ALMA. If you go to this address, you get this web page where you can query again in a similar way as I mentioned before. So you can query either by coordinates or by projects. And each of these lines have a lot of information along the line. I cannot show here, but you can get information in terms of resolution, in terms of frequencies, etc. So a lot of information here. So these examples, EVN, ALMA, are examples of data archives, but there are also published data related with surveys and legacy projects. And here you have a summary of some in the radio. So here you have the frequency of the surveys, angular resolution, sensitivity, the probed area, things as NVSS with VLI. It's a northern survey at 1.4 gigahertz in D configuration that gives you so angular resolution. You have another survey that is first, that was also done with Vlbi in B configuration, gives you a better resolution. SAMS, it's a kind of the equivalent of NVSS in the southern hemisphere. NVSS was done in the northern hemisphere, and so on. You have very recent surveys like lots with LOFAR. And so you can go to these surveys. You can do a Google and find where the surveys are, and the surveys give you maps, give you fluxes, give you a lot of information. A couple of surveys give you something that I think that's very handy. That's these image cutout services. So you don't have to do too much. If you want just to have a quick info of the map of a radio source, if it was observed and detected, it gives you just a little map. Here with first at this address, you put coordinates, you set your image size, and you choose the type of return that you want. If it's a GIF, if it's file. Here it's a GIF, so and you get this quick image, extracted image, just to make a quick check. LOFAR also offers this service. So here again, you put a position, a central position, and you can, of course, you can set your field, the size of field of view, and then you obtain something like this. So it gives you different fits files. You can click and it pops up the region, the image. Another place that has massive amount of data is the one related with Mojave. So Mojave is a long-term program that has been monitoring AGNs and try to study their brightness and polarization a long time. So it's a multi-epoch survey. And this with Vlbi at 15 gigahertz. And they have a very complete webpage where you can find a lot of information for the objects that have been observed. So it's a list, it's not an all sky survey like NVSS or FIRST. It's a list of objects that are being observed a long time. If your object is one of them, you can go to this web page here. And again, I did the exercise of choosing the one that I have been following in the other archives. And if you do that, you get this kind of information, which this is a static print screen, but it's very nice because what gives you is the multi-epoch maps in a gift, in a movie. So this is a movie. In this movie, you can see the variation of the total intensity along time, also in polarization, and they also add information from other catalogs and other databases. For instance, here you have maps from VLA. There is also more information in this dedicated link for each source, like for instance redshifts, and here they put the gamma ray association with gamma ray telescopes. And also you can download the FITS files and do more analysis, further analysis. Now, so far I have been talking about radio data, but sometimes you need to know more about the source, and you need to know more about the counterparts of the source in other wavelengths. And this is kind of when you do a checkup, you have to do several tests, blood tests, maybe X-ray plates, echoes, I don't know, several things in order to see how is your body, to understand your body as a whole. And here in astronomy is the same. When you are analyzing or studying an object, only by knowing what this object is in a part of the electromagnetic spectrum does not give you the whole picture of the phenomena. So here is an example. For instance, you see that an object doubling flux density between two observations into service. You need to dig more information to understand what is going on with this object. So if it's true that there is massive amount of data in the radio band, and I try to illustrate it that with the examples of the surveys and data archives, it's also true that the same happens in other wavelengths, from say the millimeter, the infrared, up to the gamma ray. And so you have the opportunity to dig that data, and because it's also available online, and in this way to better characterize your source. Not only, of course, you can dig on the data, but you also can dig on information in literature that is also available and can also be queried. And I'm going to give you some examples. Vizier is one of the most complete platforms where you can find most, if not all, the published astronomical catalogs. Not only they exist there, but you also can query them, which is very, very handy. So you can query by different ways. You can query a catalog by itself. Say you want to do some statistical work on objects that were observed with some catalog, I don't know, something that you want to or you need to cross-match a catalog with another catalog, something like that, and you can query catalogs in Vizier, or you can also query sources or regions. So again, you put your coordinates, again, I'm using 3C279, and you query a region around this coordinate. There are more filters that you can fine-tune your query. You can select catalogs by wavelength. There is a panoply of possibilities. Say that I query Vizier for this object, and I get a list of the catalogs in Vizier that have information on this object. For this object, for instance, there are 168 catalogs that contain information on the object. And then, as you see, you can further filter the catalogs by imposing something. For instance, say that you only want to know information that's related with the optical band, or you only want spectrum, so you can further refine your search. And then when you are happy, you select the catalog of your interest. You can do it also in different ways. Here I'm just showing you the most simple one, is just to query the catalog. And here I have in this case is the eMarlin catalog. And there is the software shows me the type of information that is available. I can ask the web interface to give me all the information, or I can select the information that I want. I can limit the number of lines or I can put a limit and I get all the catalog. I have many different possibilities to query. Of course, if I was interested in getting all the Marlin archive, for instance, that is available in Vlbi, I could come here in the first place and put eMarlin and, for instance, query just eMarlin catalog. Another very nice platform is Simbad. Simbad, it's different from Vlbi. Vlbi, it's a platform that has catalogs. Simbad, it's a different thing. Is a database that makes cross identifications between catalogs. So say, for instance, again, 3C279, I want to know what Simbad has on this object. And if I query based on the coordinates, I get a list of objects that are identified in the field of view that I query. So centering the coordinates of that I put around a certain region. And in here, it's a list. You don't see it all, but there is a list. And in here, I have in the sky all the objects that Simbad has information in this region of the sky. Because I'm only interested in this one, I click in this one, and I get this kind of information. So it's a different type of information. It's information that is connected with different sources of information. So for instance, here you have a list of the fluxes at different ends of the object, and these fluxes come from different in this case from different catalogs and from different literature. You have more information here. You have redshifts, and you can click on all this information here to get more info. And here you have a summary of all the possibilities that you can query. Now, if you are more focused in extragalactic stuff, NED is the best place to begin. NED is also an astronomical database that, again, cross-identifies objects in different catalogs and delivers that to you. So you can also, like in the other cases, do different queries. Here I'm querying again this object 3C279, and I get a list of possibilities. So these the possibilities are objects that are detected around the position, the initial position that I query, and and already gives me some information. So it's always important to see the distance um, of the object that is referred here from the initial coordinates. So let's say that I want to this is the object that I'm interested. So I click here and I get this fantastic piece of information on this object that is the result of cross identification from different catalogs, surveys, etc. So all these tabs give you information on this object. So this is an overview, but if you click here, you have different kind of information like redshifts and the references of those redshifts, so literature. You also have this very nice, it's the photometry, and NED also produces a spectral energy distribution with that photometry. So photometry that is available for all the wavelengths. Gives you spectra, if exists spectra, images, the literature, the list of articles that this object is referred. So can be different things. This object can enter this article because it belongs to a sample, or because it's an article only devoted to this object. You can have different scenarios here. And also, which I found it's very handy, it's these notes. So if in these articles, in these papers, there were notes dedicated, there was some text dedicated to this source, NED also shows that information. Another place that is very handy, it's Sloan Digital Sky Survey. So of course, this platform is about Sloan data, so slower images or spectra, but and you can query again by putting a coordinate, and then gives you information on the field of view around that coordinate. If it was observed, and I'm querying now this object here, you get this kind of information. So the first bit of it, it's all related with SDSS data, so the images. You get magnitudes, you have some flags, some information. You can download the data. So fits files on imaging or spectra. And SDSS also makes cross identifications and tells you if this object was observed or detected in other with other telescopes. That said, these might not be complete, or so careful. And also gives you the possibility to have a net search, a SIMBAT, or a ADS that I'm going to refer in a minute. So links this object with what is in net on this object, on SIMBAT, on this object. So you click and you get all the information. Also gives you, if it exists, an optical spectra, and has a nice interactive web page where you can interact with spectra and get redshifts, identification of lines, see the spectra, etc. It's very important to also to dig in the literature to get information on the subject of your interest. And the best way to do it is via NASA ATS. Has a platform of almost all the published papers, proceedings, etc. So if you go there and you can query this database, and you can query via different fields. So author, abstract, say you want to know everything about 3C279, for instance. So it queries all the papers that were published where this word appeared, either in the abstract title. So you get something like this, where you have a list, a huge list. In this case, there are 2,800 papers referred on that somehow this object is mentioned, and some more non-referred articles. If you click in one of these papers of interest, you get to another environment, and that gives you also the possibility to see if there is a link to archive. In the archive, you have free versions. If it exists, you have free versions of the paper. Sometimes the papers are not freely available, depending on the journal. If you have problems with that, please contact with a direct tutor that may try to help you. Now, so up to now, we have been talking about archive data, published data. I would like to end the talk to also to mention a couple of useful tools that help you to display the data, to deal with the data. And beginning by Aladdin. Aladdin, it's a kind of interactive sky atlas that allows you to visualize the images, but also to superimpose images with entries from catalogs or databases, and that's very handy. That helps a lot to try to dig more information on the objects. So there are two versions of Aladdin. One version is this Aladdin Lite that you, if you go to this web address, you can click and you have in your browser a small version of Aladdin in terms of tools that you can use. So it's good just to have a quick look, but it's not as powerful as the desktop Aladdin. So here again, you put coordinates of a target, and it gives you the target in the field of view that you can choose. You can ask to put as the image, the background image, you can choose from a list here. Here is the SS image, and then you can superimpose other catalogs like these ones here. So for instance, for 3C279, this is Pan Stars, I think, image, and then yes, it's the base image layer, it's Pan Stars that I choose. And then I superimposed because I wanted to know which were the objects in this area of the sky that were detected by Gaia. And I asked, and so here are the detections that Gaia have in this area of sky. But if you go to the Aladdin desktop version, you can do a lot of stuff, much more much more sophisticated analysis. You have a collection of data that is available, either images, databases, including Simbad, etc. Here I am showing you the collection related with images. So the whole collection is in Aladdin, but then Aladdin tells you if for that region of interest, the data is available or not, and tells you in terms of colors. So everything that is in green, it's in the field. So the telescope observes that region. If the telescope didn't observe that region, it's out of use, so it's in orange. And you can load data from these catalogs and download the data. Here I have an example. What I did was, for this galaxy, I choose to have several. You can choose here to have several little screens. And for each little screen, I choose a different wavelength, an image at different wavelengths. So here it's optical, here it's near infrared, here it's radio. I can match the position of my cursor in all the different screens. So every time that I move my position here, I'm also moving the position in the other images. And this allows you to do a lot of things. You can study, for instance, if in a certain region the object emits or does not emit in a certain wavelength, etc. So there is a panoply of things that you can do here. For instance, in this case here, you have the image is a Sloan image, or optical image, and then superimpose, you have all this data from different archives and from different surveys. So then you can dig and understand where, for instance, the radio at a certain frequency is detected, or regions where other kind of emission is emitting. So we have been talking about FITS files. One of the software that I think that you know, it's CASA, but there are different tools and that are available. SEO image is used very often to analyze optical images, for instance. So it's a tool that you can load FITS files and do analysis with data, some statistics. You can also compose false color images. So it's also a very powerful tool. And you can go through the documentation. They have very good examples, and it's very handy. Another very handy tool is this database in SSDC Sky Explorer that allows you to see the spectral energy distributions of the objects. So here what the platform does is, after you query for an object, it cross-identifies the object with a list, a large list of catalogs in that, and gets everything together and builds the spectral energy distribution for the object, and also can, if it's the case that the object has multi-epoch observations, can also produce multi-frequency light curves. So again, you can query this by name or by coordinates. Again, I query by the name. And when you query, you can ask for a set of the object. And the software also gives you a list of the data so the photometric data if you want, and you can do the spectral energy distribution with other tool of your choice. But here the software produces the spectral energy distribution for you. This is an object that, of course, has a lot of data. Not always is the case. So, but this illustrates very well the potential of the software. So this object has detections from the radio up to the gamma rays. And here you see the catalogs that are available. If you click in each radio, infrared, blah, 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 it gives you at each part of electromagnetic spectrum the available catalogs, so the catalogs that the software query for these coordinates. You can select or deselect the different catalogs. And then you have here many possibilities. You can do things like time filtering. So you only, for those objects that have multi-epoch data, you can filter the period of time. You can do something that is very handy also, is to ask to the software to show you the instruments sensitivity. You have a list of instruments, and the software can show you in your set the sensitivity of the instrument, and then you can understand if an object was, for instance, not detected with a certain telescope from its seeds, from its spectral energy distribution. You can have an idea if it should have been or not detected, if it's a very faint object, even if it was observed, even if it was in a region where the telescope was observing it, that region, it didn't get detected because it's too faint, for instance. It's very handy. You also can try to fit functions to the spectral energy distributions. You have a list of different possibilities, and you also have templates, for instance, to put a template of host galaxy, etc. So very handy stuff. I'm going to finish by talk about a very also powerful tool, that's TopCat. TopCat, it's a wonderful software to work with tabular data. Has a potential to operate with tables, big tables. You can do a lot of things to display the data of your tables, to do plots, histograms, etc. But besides all that work with tables, and for that, of course, you have to have the table. So one thing you could get with, for instance, Vizier, you could get a catalog or a sample, and you ingest that catalog to TopCat and do operations in it. It's also very good to cross-match catalogs via coordinates, etc. But besides that, can also do cross identifications through by querying different catalogs and data archives that are online. In order to just to give you an example, I ingested to TopCat the coordinates of the 3C279, and I want to make a query in some catalogs. For that, I am going to query, I'm interested in understanding if this object was detected by Gaia. And in this case, I want to query the last data release of Gaia, EDR3. And so I put here these two keywords, Gaia, EDR3, and the software returns a list of catalogs that contain these two words, and I choose one of them. I'm going to choose this one. I have to fill in some information. So my input table is this one. I could add more tables here. Is this only have one, but in this case, it's very clear I could have more, so I had to choose, and I had to say the software, the columns, which columns, in which column corresponds to the right insertion and the combination of the objects, and I have to say which is the radius to query the data. So, and after doing that, I get a new table with the data from, in this case, from Gaia. And with that data, I can do different things. I can do plots, I can do whatever I want, histograms. I mean, you have different possibilities. But what I wanted also to show you here, because I think it's very handy, is you can also use this environment that allows you to display cutouts from a list of catalogs according to the coordinates of their objects. And for instance, here I choose DSS, and when I go through my table that is ingested in TopCat, I click in one of my lines, one of my objects, and immediately it displays me, in this case, the DSS image of this object. So imagine that you have a list of objects, and it's a very quick way to have a check. For instance, what is the optical counterpart of their objects? It's just by clicking and a pop up with the image comes. So this is quite handy. And okay, so in conclusion, you have massive amount of data that is available, that you can download, that you can process further, that sometimes it's already in the final version. So you have fluxes, you have maps. Other times, if you want, you can download the raw data if it's available, and you can reduce again the data and then get again maps or other kind of information. it's important to pick always referred publications, to dig also more information on your subject of interest. Try to keep on referred publications, because in the internet there are a lot of information that it's not always very accurate. A good way to start digging the massive amount of data that is available is Net, and then refine your search by using other tools. Here I mentioned some of the tools that I think that are quite useful. If you use archive data, be sure to make an acknowledgement, because it's quite important for the, the institutions and the people that are doing this massive amount of work. And in terms of available publications, um, it, I think that in principle you should be able to get um, the information, but if you have problems, contact us. And yeah, you are an astronomer, but you are also a kind of a digital detective. So trying to find out what we know about the source, it's a kind of a detective in the web. Thanks.